Hey, everybody. Good morning, afternoon, or evening, wherever you're joining us from. We're really glad to have you here. My name is Brandon Rees, Product Marketing Manager here at EMQ Technologies. And today I'm joined by my colleague, Jinyu Liu, who is one of our core platform developers at EMQX. And today we're really excited to dive into something that's still new for a lot of teams, and that is how do you connect IoT devices with AI systems at scale, right? Using something called the Model Context Protocol, or MCP, over MQTT. And so we'll break down what that means, how it works, and ultimately why it's such a powerful combination, right? And especially if you're working with resource-constrained edge devices or looking to deploy generative or agentic-based AI in the real world. So I'll go ahead and kick things off by walking through the big picture. So a quick look at what MQTT is, if you're not familiar or using it already, the four major types of AI, and why MCP is such a breakthrough in this time. So then Jinyu will take over from there and do an over how things look in practice with a live walkthrough and demo. So more of the technical side of things. And then toward the end of the session, we'll also launch a quick poll just to collect your honest feedback and help us keep improving these webinars going forward, right? We want to make sure that it's in a format that is good for you, that's covering the topics and such that you're interested in. So please do spend the time to go through that. It really means a lot to us. And of course, we'll leave time for live Q&A at the end. So do feel free to drop your questions into the chat at any point, and we'll get to those and as many of them as we can before we close. And if for whatever reason we're unable to capture all the questions, please still submit them and we will reach out to you after the fact and make sure you get those answers. So with that, let's go ahead and jump in. So I wanted to start with MQTT because it's really the foundation for everything that we'll be talking about here today. MQTT once stood for Message Queuing Telemetry Transport. Today it's just the acronym. But it's a lightweight messaging protocol. It was originally developed in the 90s by IBM for oil and gas industry, where the connections were really expensive, bandwidth was really limited, and reliability really mattered. So fast forward to today, and that same protocol has become really the gold standard for IoT communication. And why is that? And it's because it's designed to be low bandwidth, low power, and in real time, right? So it's really perfect for those kinds of devices that power connected products from sensors and machines to AI-driven applications. So MQTT uses a publish-subscribe model, as you can see in the diagram here, which makes it much more scalable and event-driven than, let's say, a direct device-to-device communication. So devices don't have to know about each other. They just publish or subscribe to topics, and a broker, which you see at the center there, really handles the message routing. It's incredibly lightweight, as I mentioned. Messages can be as small as 2 bytes, which makes it ideal for devices running on limited memory or battery. And you also get the flexibility in how messages are delivered. So thanks to MQTT's 3 built-in quality of service levels, there's QoS 0, which represents at most once. So it's really a fire and forget with no real guarantees. QoS 1, which is at least once. And it guarantees delivery, but you may end up with duplicates on the backside. And then for QoS 2, exactly once, it is the most reliable, but it does give you the added overhead, does often lead to a little bit more spend, but it does help with hygiene and clean things up, right, your data. So when we talk about getting AI models ready to interact with the physical world in a way that's reliable, fast, and efficient, MQTT is the transport layer that makes it all possible, which is what we'll be talking about more today when Jinyu jumps in here. So before we jump into EMQX and MCP, which is going to come in just a bit. I wanted to take a minute to talk about AI itself, right? Because when we say AI, we're really talking about a growing stack of different capabilities, not just AI broadly as a whole, one blanket term, right?